Okay, so as y'all are getting in, you can unmute and share, or you can type in the chat. But I'm curious to know, does anyone know why I put these two pictures on our intro slide today? See who's been listening to me. Okay, so comparing size, okay. That's part of it. So I like the word comparing there, yeah. Let's see. So yesterday, I talked about how in the last unit, I kept referring to the bowling story. On this unit, I said I'm going to keep talking about the Kool-Aid. And you remember what I talked about with the Kool-Aid? Mixing it, right? Okay. So what I think of, and I'm trying to connect it real world for you guys, proportional, essentially in making Kool-Aid or lemonade, because this is yellow, okay, is having the right portion, and we see that word here, portion within the word, of ingredients. And so I know if to make this small pitcher, I need so much lemonade powder and so much water, I put that in there. But if I want to go make a pitcher that's twice its size, I need to make sure that I double the water and double the powder. If I don't have the right combination or portions of ingredients, then my lemonade's not going to taste good. Okay, so proportions in real world is all about having those equal amounts of ingredients if I'm going to double a recipe or triple a recipe, to make sure that what I'm trying to make comes out correctly. And so, like I said, in the last unit, I talked about the bowling quite a bit. Here, y'all are going to hear me talking about making that lemonade or making that Kool-Aid and making it taste good. Okay, so proportional. What does it mean? Okay, in real world, we're making my lemonade taste good. But let's go on to our first task. I want to hear from y'all. Okay, so for time purposes, I'm going to go ahead and start talking about what we see so far. Okay, and what I see so far is all correct. Okay, and so this is a really low risk task for you guys, just to tell me something that you know. So I read this sticky note right here, there's trees and apples. That is true. Okay, if you can tell me that, then that tells me you're reading the table, which is great. Okay, times 13. So I'm curious, for those of you that have not yet responded, is there another way that I could talk about this number 13 in the table? Okay, so I'm gonna pose that question for you, for those of you that haven't responded, but let me go ahead and go through the rest of these. So I got, for every 2 trees, there are 26 apples. I like it. And I'm assuming this was meant to say the most apples is 146, and there are 12 trees. Ooh, beautiful. Oh my goodness, someone made an equation. Someone made an equation, and a correct one. So don't put maybe, show your confidence. Okay, so this times 13, what I see here in this equation is that we take the x value, the number of trees, multiply it by 13, and it gives me the y value, which is the number of apples. That is awesome. Okay, so we have not hit on the one thing. Good job, whoever put that. Yes. Okay, we haven't hit on kind of the key piece that I wanted to focus on. Okay, but I'm going to come back to this sticky note right here. Okay, it says for every 2 trees, there are 26 apples. Okay, right there, you gave me a ratio. And that ratio that you gave me is, you said, for every 2 trees, there are 26 apples. Okay, I can then go and simplify this ratio. Okay, I'm going to simplify this ratio, and look what happens. Both of these numbers can be divided by 2. And when I divide by 2, I get the ratio 1/13. Okay, let me take another set of values on here. So let's say if I have 39 apples on the 3 trees. Okay, so 3 trees gives me 39 apples. What do you think that's going to simplify down to? Okay, both of these values can be divided by 3. So 3 divided by 3 will give me 1, and 39 divided by 3 gives me 13. Okay, so I really wanted to kind of hone in on this one right here, and that's why I asked, like, is there another way that we can talk about this 13? Okay, and so when I say times 13, I might have said the phrase 13 apples per tree. Okay, that's my unit rate. Okay, so I see that my unit rate is that multiplicative relationship of times 13. It is that rate being multiplied times the variable in my equation. Okay, but the important piece here is that no matter what tree I'm looking at, okay, it's always going to simplify down to the same unit rate of 13 apples for every tree, no matter what. Okay, so that's going to kind of push us into some of our prior knowledge into our current knowledge. Okay. When I went to Google, okay, and so what I'm doing right here is modeling for you things that you can do, okay? When I go to Google, I went into Google and I said, define proportional, and this is what came up, okay? This was the word definition. Proportional relationships are relationships between two variables where their ratios are equivalent. Okay, so just like in our trees and apples, it reduced every time to 13 apples a tree. Okay, so this example popped up when I also clicked on define proportional. So when I look at this example, I can see the times 3 times 3 times 3 relationship. But if I set these up as ratios of time and distance, okay, I was comparing 2 minutes, or after 2 minutes, I went 6 feet. After 6 minutes, I went 18 feet. Both of these ratios will simplify down to 1 for every 3, meaning 3 feet every 1 minute, 3 feet every 1 minute. And that's also where I see that times 3 multiplicative relationship. Okay. When I come over here, and this story is a lot like the bowling story. So remember, before I play any games, so when this is 0, I still have to pay that amount for the bowling shoes. So when I have that extra cost in there, those bowling shoes, when I create those ratios, they don't simplify to be the same because of the shoes. The shoes kind of throw off my numbers a little bit. Okay, so when that happens, that is non-proportional. So definition of proportional is comparing those values. I come up with the same ratio every time, or the same unit rate, 3 for every 1. Okay, so that's just a real quick glimpse into the defining of it. Okay, so here's what I want us to do now. Exactly correct. So see, proportional means to contain or state that I have equivalent ratios. Okay. When our ratios are equivalent, that means that they all simplify down to the same unit rate. Okay. So remember, our goal earlier this week was to use the unit rate, but now we're going to move forward with it. What can we do with that unit rate? Okay. There's a lot of power behind it. Okay, so here's a problem from our slides from earlier this week. Okay, I have given you this ratio that we got from the problem that 5 bags weighs 35 pounds. I want you to take some time right now, use your draw tool. You can use the pen or type, and I want you to fill in the numbers that go in these 4 blanks. Okay, so let's go ahead and take a look at this. For the most part, you guys were filling it in fairly quickly, which tells me we have some confidence here. Okay. Now I want to hear from you in the chat. Okay. And you can just say me if that applies to you. I want to know how many of you took what we had, found the unit rate, and then just added 7 every time. No, how many of you said, okay, for 1 bag it's 7, so then as I'm going up bags, I'm going to add 7, add 7, add 7, add 7. Okay. Did I have anyone in here that kind of did that idea? Okay, if it was 35 for 5, we divide, figure out it's 7 for every 1. Okay, so then another 7 pounds, another 7 pounds, another 7 pounds. Okay, so I'm seeing some of you added, and then I'm hearing that some of us multiplied as well. Okay, so there's power in knowing that unit rate. I can repeatedly add the unit rate over and over again. Or yes, I can multiply because I see that multiplicative times 7, times 7, times 7, times 7, times 7. Okay, so here's what our goal is today. Okay, our learning target today, okay, and I'm going to be very explicit with this, says I can, okay, let me get my pen back. And I really want my pen because I want y'all to, I can set up, okay? So we are not doing any solving today. It is solely, can I set up this proportion, which we know means now equivalent ratios, to solve prediction problems, okay? So let's kind of look at what that looks like and then talk about the why behind it. Okay, so if I come back to our problem that we just did, okay, I can find that unit rate and I can kind of shift over, okay. A lot of you, I know right now, your thought, because we've been working on it so much, is you would divide, find that it's 7 per 1, and multiply by 3. Now, I'm going to tell you, if that is your preference and that's what works for you, by all means, go with it. But here's what our goal is for today, okay. Our goal is to try to transition to this place where we remove this step 3 part, okay? We want to go straight from step 2 to step 4, okay? Now, there's a way to do this, okay? We're not talking about solving just yet. We are just talking about setting up, okay? So what your task is today is to read a problem like the ones we had yesterday, and you're going to set up a proportion that looks like this. I was given that it is 35 pounds for 5 bags, and I want to solve for how many pounds is it for 3 bags. Okay, so our goal with setting this up is, again, skipping this middle step. Okay, but we know that both of these have the same unit rate, so I can still use that unit rate method. Okay, tomorrow we will take a look at how we solve this. Okay, but today it's just setting it up. So this is what you're going to be setting up in your practice problems today.